and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary. Thank you guys for tuning in with me. In today's lesson, we are going to continue to work on representing fractions that are greater than 1. And we will represent the answers for those fractions using two forms, improper fractions, and mixed numbers. So go ahead and turn to your workspace, pages 22 and 23, and we're going to work through those pages with you. I'm going to work through those pages with you. Before we begin, I just want to go ahead and review some of the fraction names, starting with 1 whole. And then the red ones are the halves, and you need 2 halves to make up 1 whole. We move down to the fourths. When you take a whole and you break it into 4 equally sized sections, you get fourths, and you need 4 fourths to make up that 1 whole. Then we have our eighths. If you take a whole and you break it into 8 equal sized parts, the parts are each called 1/8, and you need all 8 of those eighths to make up the whole again. Last but not least, we have our sixteenths. If you take a whole and you break it into 16 equal sized parts, each one of those parts will be called 1/16, but you need all 16 of the sixteenths in order to make up the whole. Now what you will notice is when you look at my mouth as I'm referring to these fractional parts, you will see the at the end. And that's how you know in this lesson I'm referring to a fraction. The word fourth sounds a lot like 4, but at the end of the word fourth, there's the TH there. The same thing goes for eighths and sixteenths. Okay, so in moving into this lesson, looking at page number 22, it says, show what you know. Build a train to match. Build a train of equal length using pieces of one color. Write a shortened equation and write the sum as a fraction and, if possible, as a mixed number. So at this point, I hope you guys have your writing materials and you have your fraction strips. If you have not made an additional set of fraction strips, because for this lesson you will need at least 2 sets of fraction strips. For now we can draw them out, but in the next lesson after this, you will definitely need to go ahead and create an additional set of fraction strips. So let's take a look at the train on page 22. So we have a half. We have 2 fourths. Another half. And we have 1/8. I'm going to go ahead and slide these pieces over to create more space. And we want to write all of the possible equations for the answers to this fraction train. And if you notice, there are 5 fraction tiles up here. This is an extended version of the game Roll 5. You can play this game we're working on the workbook, but when you're not working on the specific problems in the workbook, you can get more practice for this style of fraction exercises by playing Roll 5, which is in your workspace workbook, and I believe it is on page, bear with me, page 18. The rules for Roll 5 are on page 18. Okay, so here we go. 1/2 plus 1/4 plus another 1/4 plus 1/2 plus 1/8 is equivalent to which fraction? Before we get into this, I just want to say that when you are adding fractions and the denominators are the same, It's very similar to when you hear me counting, when I say 1/16, 2/16, 3/16, 4/16. Oh, it's 4/16 here. You're pretty much just adding the top, you're just counting and you're adding how many pieces you have. But when you are adding fractions and the denominators are not the same because the size of these fractions are different sizes, like in this lesson, it's a little bit more challenging to find the total or the sum. So we will use one type of a fraction, and we will use as many as we can to create a fraction train that's equivalent to this fraction train in length, so we can find a total. So let's go ahead and we're going to start with the eighths. 1/8, 2/8, 3/8, 4/8. Half is equivalent to 4/8. Let's count on 5/8, 6/8, 7/8. Have we matched the total length of the fraction train yet? No, we have not. So we're at 7/8. Let me just double check. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. 8/8. 9/8. 10/8. 11/8. 12/8. And 13/8. So we know that 1/2 plus 2/4 plus 1/2 plus 1/8 is equivalent to 13/8. And if you look at the fraction 13/8, you will notice that the 13 is at the top of the fraction in the numerator, and 8 is in the bottom half of the fraction in the denominator. What do you call fractions where the numerator has a bigger number or greater number than the denominator? Improper fractions, and we know that improper fractions are greater than 1/2. Okay, so now we're going to try this again using 16ths. Well, actually, we're not going to try it again using 16ths. We are going to try to show this total as a mixed number. So 1/2 plus 1/4 plus 1/4 plus 1/2 plus 1/8 is equivalent to. So right here I can see where we have 1/2 and 1/8, 2/8, 3/8, 4/8, 5/8. So it's equivalent to 1 and 5/8. So 1/2 plus 1/4 plus 1/4 plus 1/2 plus 1/8 is equivalent to 13/8 or 1 and 5/8. So let's talk about it. If this fraction train at the top can be or is equivalent to 13/8, and the fraction train at the top is also equivalent to 1/2 and 5/8, then 13/8 has the same length of measurement as 1/2 and 5/8. And we talked about that before. If this is equal to that, and then that is equal to this, then this and that are also equal to each other. So my top fraction train is equivalent to 13/8, and my top fraction train is also equivalent to 1 and 5/8. So then 13/8 is also equivalent to 1 and 5/8. Let's try another problem. You guys are doing pretty good. The next one we're going to do is we're going to work on number 1, where you have a half. Let me move some of these down. They're going to be out of place today because I don't want to spend too much time trying to get them all neatly organized. So we have a half, a 16th, 1/4, another half, and another 16th. We're going to use the eighths. So let's write this down. Let's drop it down just a little bit. One half plus 1/16 plus 1/4 plus 1/2 plus 1/4 is equivalent to. And we want to find the fraction that it is equivalent to. We'll use eighths. 1/8, 2/8, 3/8, 4/8, 5/8. Can you guys see me? 6/8, 7/8, 8/8, 9/8, 10/8, 11/8, 12/8. We don't have enough eighths to figure it out. Well, we do have enough eighths, but we have a problem here. There's a section left that we haven't matched, but the eighths are too large. So let's try to use the 16ths. And I'm going to pile up a bunch of 16ths to match the length here, and then we'll go back and we'll count the 16ths together. So at this point, I'm not going to count them. Just going to put a bunch of them up here. Enough to match the length. Because when we talk about equivalency with fractions, it's all about matching the length and covering the same amount of space. So if you guys can see me here. Have we made a long enough train yet to match the equivalency of the top train? Not quite yet. How many 16ths do you think are going to be equivalent to the sum of the top train? That's a really good guess. I know it's definitely going to be greater than 1/16. Okay. Have we used enough 16ths to match the equivalent length of the top fraction train? Yes, we have. So 1/2 plus 1/16 plus 1/4 plus 1/2. You know what? I can kind of shorten this. I can shorten this because there are some pieces in this top one that are the same types of fractions. So if I join them together, I can shorten them and rewrite this. I didn't change any of my pieces out. I just switched the order of my add-ins. And remember, even when you switch the order of your add-ins, it doesn't change the total of your sum. You're still going to get the same amount. So I'm going to rewrite this, and I'll just change some of the add-ins around. I'll write it over here. So we have 1/2, 2/2, 2/2 plus 1/4, 2/4, 2/4 plus 1/16 is equivalent to. So I just joined the halves and that's how I got the 2/2. And then I joined the fourths, and that's how I got 2/4. And I only had 1/16, so I left that the same. So this is the old version. It's a little bit more longer, and this is the shortened version of my add-ins. Okay, let's count how many 16ths this is equivalent to. Are you ready to count the 16ths? Great, here we go. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, 15/16, 16/16. I'm just going to mark my space that this is 16/16, 17/16, 18/16, 19/16. I have to slow down because that's a tongue twister. 20/16, 21/16, 22/16, 23/16, 24/16, 25/16. Did you predict that the total length of 16ths needed to match the equivalency of my top tray would be 25/16? You did. I would not have ever been able to guess that, but good job to you. So 2/2 plus 2/4 plus 1/16 is equivalent to 25/16. So now we're going to take these 2/2 and these 2/4 and the 1/16, and we're going to see what the total of this would be as a mixed number. And we'll use our whole to mark our mix, to help us out with our mixed number. Now, the reason why I marked this line as being the line where the 16/16 is because I know that 1/2 is equivalent to 16/16. 1/2 is equivalent to 2/2 and 4/4 and 8/8. It's all of the fractional parts. I shouldn't say broken parts because they're equivalent in size. So I'm thinking that from end to end, my 1/2 strip should go from here to there. Let's see if I'm correct. Ta-da! I am. 16/16 stops here. 16/16 is equivalent to the 1/2. In addition to the 16/16, I have the rest of these 16. So I have 1/2 and 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16. I have 1/2 and 9/16. There is the mixed number representation of 2/2 plus 2/4 plus 1/16. It's also the mixed number representation of 25/16. 1/2 and 9/16. So let's just write this out as clear as day. 25/16 is equivalent to 1/2 and 9/16. Here's a trick question. Well, it's not really a trick question. It's more like a trivia question. How many 16ths are equal to that 1/2? 16/16. I knew you were paying attention. Okay. Let's go ahead. So you're going to complete number 2 and number 3 on page 22 on your own, and I know that you can do it. Let's work on page 23, and I'll help you guys out with number 4. Okay, you guys are doing a great job. Is it easy for you to see how to create fractions that are greater than 1? Yeah, I can see how it will be easier because once I pull out that whole strip, the fraction strip, you can see, okay, all of these pieces are the same length as the 1/2. So anything else that comes after that will be extra with the 1/2. That's how you get your mixed number. 1/2 and some more fractional pieces. Now you'll see that mixed numbers can be greater than 1/2. You can have 3 holes in something. But in this lesson, we're starting out with the basics of seeing how you can have a bunch of fractional pieces, and some of them are the same size and length as just one whole. So you have one whole and some extra pieces. Alrighty then. Let me just drop these down. Don't want to spend too much time organizing here. All right, I'll stop singing. I know my kids don't like it when I sing, so just move some of these out of the way. All right, so for the next one, we have 2/8, 1/4, and it looks like 1/16. So we have two 1/8 pieces, and we have 1/16. Now, usually, I would write this as 1/8 plus 1/8 plus 1/4 plus 1/16. 16th. But we can shorten our equation. 1/8 and another 1/8 is how many eighths? 2/8. So we're going to write it just as that. We have 2/8 plus 1/4 plus 1/16. We want to know what this is equivalent to as an improper fraction. And we'll do it again. 2/8 plus 1/4 plus 1/16 is equivalent to, and we want to know what's the sum as represented by a mixed number. Because we have a 16th here, and the only size pieces that I have that are equivalent to a size that's as small as the 16th is another 16th. So we are going to use our 16ths here. So we'll just line them up, and then we'll go back and count them. We want our trains to be equal in length. All right. Have I created a train that's equivalent to the size of this train? Yes, I have. Let's go and count how many 16ths. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16. So what we came up with is 2/8 plus 1/4 plus 1/16 is equivalent to 9/16. Let's see how many, let's see if we can write this as a mixed number. So when I place the whole under the two fraction trains, did it match up to the length of the fraction train? No, it did not. In fact, the whole is longer than the original fraction train. Now let's talk about that a little bit. That means two things. That means I can't represent 9/16 as a mixed number because there aren't enough fractional pieces to even make up one whole. Let's also examine the fraction 9/16. When you use 16ths to create a whole, how many 16ths do you need to make one whole? You need 16 16ths. 9/16 is not all 16 of the 16ths. So you don't even have enough to make one whole. 9/16 is what we call a proper fraction. It's a regular fraction. If you look at the numerator, you have a 9. If you look at the denominator, there's a 16. This is a regular fraction. An improper fraction would have a larger number up top and a smaller number to the bottom. So you can't represent 9/16 as an improper fraction, and you can't represent 9/16 as a mixed number. 9/16 is just a regular fraction. Okay. So let's review before we close out this video. What did we learn about improper fractions and mixed numbers? When you're looking at a fraction, how do you know that it is an improper fraction? Let's take a look at 13/8. Is 13/8 an improper fraction, a mixed number, or regular fraction? It is an improper fraction. When you're looking at an improper fraction, the number in the numerator is greater than the denominator. Remember, boys and girls, the denominator, or the bottom part of the fraction, tells us how many equal-sized portions the whole was broken into. 8. So that would represent my eighths. The numerator, the top number, tells me how many of those eighths are being described. 13. Then we have to think about, well, how many eighths do I need to make up one whole? I only need 8/8. If we are referring to 13/8, I have more than what I need to make up a whole using eighths. I only need 8. I have 13. I only need 8/8, but in that fraction, I have 13/8. Fractions where the numerator is greater than the denominator are called improper fractions. The prefix "im" referring to not. "Im" means not in this case. So this fraction is not proper. Proper means regular. The proper fractions have a smaller number up top and a larger number at the bottom. Now let's take a deeper look at what that means. If a proper fraction like 9/16 tells me that my whole has been broken into 16 parts and I am describing 9 of those parts, am I describing all 16 of those parts? No, I'm not. Only 9 of those parts. But when you look at an improper fraction, you're describing more than you need to make up a whole. That's why improper fractions are also called fractions that are greater than 1. If I can decompose 13/8 into 8/8, and how many more eighths? 8, 9, 10, 11, 12, 13. 5 more eighths, and you get your 13/8. 13 can be decomposed or broken into 8/8 and 5/8. The 8/8 is equal to 1. So 13/8 can be written as a mixed number of 1 whole and 5/8. A mixed number is a number that is part whole number and part fraction. Part whole number and part fraction. So we learned about proper fractions, improper fractions, which are not proper fractions, or fractions that are greater than 1, and mixed numbers. Thank you guys for tuning in with me. You guys are wonderful, awesome. Keep practicing those fractions, and I will see you next time.